In the darkness between stars, dead giants still pulse, clock precise, merciless, bright as creation's first spark, cold as its last. They are the galaxy's deadliest engines, grinding space-time, beating like the hearts of monsters long after their bodies are gone. Beyond the stars lies the cosmic unknown, where nothing is ever truly silent. A pulsar is the corpse of a sun, collapsed, compressed, spinning so fast it blurs the definition of motion. Picture a sphere of pure neutrons, wider than a city, heavier than two suns, rotating dozens, sometimes hundreds of times every second. With each spin, it sweeps twin cones of radiation across the void like a cosmic lighthouse. On Earth, the beam arrives as a rhythm so perfect, we once cataloged it as LGM1, Little Green Men, before realizing no civilization could engineer such relentless discipline. The first pulsar flashed in 1967. Today we clock millisecond pulsars whipping around 716 times per second. Their magnetic fields ripping particles from the surface and hurling them at near light speed. Radio telescopes translate the carnage into sharp clicks, faster than any drummer can dream. Their spin is so stable, a slow pulsar loses less time in a year than an atomic clock loses in a century. But these furious clocks have an angrier cousin, the Magnetar. Take a neutron star, twist its magnetic field until it stores more energy than every star in the Milky Way emits in a year, and you have a stellar grenade with the pin already pulled. Field lines billions of times stronger than Earth's shred atoms, turn vacuum into storm, and bind the crust in stress so violent it quakes. A single cubic meter of Magnetar core could power human civilization for 1 trillion years if it didn't annihilate everything around it first. On 27th December 2004, Magnetar SGR 1806-20 proved the point. A crustal snap unleashed a gamma-ray flash that outshone every star beyond the solar system. The spike delivered to Earth in 0.2 of a second the energy the sun supplies in 8 hours. Satellites saturated, radio links bent, the ionosphere puffed like a struck drum, and the blast began 50,000 light-years away. 10 times nearer, and spacecraft would have fused. 10 light-years, and our ozone layer would have boiled into space. Where does such fury arise? Rewind to a supernova. A massive star's iron heart collapses. Protons and electrons merge into neutrons. Shock waves rebound. Outer layers explode. What remains is a sphere 20 kilometers wide with the mass of Mount Everest in every teaspoon. Gravity and angular momentum spin the sphere up. The core's magnetism contracts, winding ever tighter until catastrophe is stored like tension in a bowstring. A star-quake lets it slip. LIGO, here's the distant consequences. When two neutron stars collide, their last milliseconds ring space-time itself. In 2017, GW 170817 showed that gold, platinum, and the heavy marrow of planets are forged in those collisions. A kilonova glowed violet, then crimson, then ash-dark infrared. Proof that death can be creative. Yet for all their violence, pulsars are tools. Astronomers use their perfect timing to test relativity and to hunt gravitational waves too slow for LIGO. Networks of millisecond pulsars across the sky, pulsar timing arrays, serve as galactic GPS, mapping the rumble of supermassive black hole pairs millions of years before merger. Every tick is a data point. Every missed beat hints at something huge and hidden dragging on the cosmic clock. Still, the survival instinct whispers, what if one of these engines pointed at us? Simulations place a Magnetar's kill radius for complex life at roughly 50 light-years. Inside that bubble, a single flare could strip atmospheres, crack DNA, ignite runaway chemistry. Even an ordinary pulsar, if aligned just right, could bathe a planet in particles strong enough to erode ozone and seed mutation. For now, our neighborhood is calm, but the galaxy rotates. New giants will rise, and some will die badly. Stand on a neutron star, if physics would let you. A single step would weigh more than a mountain. Atoms collapse. Chemistry ends. The iron in your blood merges with the crust without a sound. Time dilates. Rotation so rapid the horizon shifts in milliseconds. Magnetic storms painting auroras taller than Olympus and hotter than bomb cores. Sound cannot travel in near vacuum, yet the crust rings with star-quakes that vibrate through the lattice of degenerate matter like cathedral bells. Imagine 6 kilometers of neutron-rich crust shearing by 2 centimeters. Energy equal to 100 quintillion tons of TNT detonates, field lines snap, reconnect, whip particles to light speed, and a fan of gamma radiation screams into the dark. Somewhere, a radio telescope hears one extra tick in an otherwise perfect rhythm, and a civilization 3 spiral arms over never learns how close oblivion came. We, meanwhile, orbit a quiet G-type star on a fragile bubble of air and hope. We map pulses, count photons, and model cataclysms on supercomputers the size of closets, seeking to understand machines older than humanity's collective memory. Knowledge is our only shield, curiosity, our only weapon. Because if a Magnetar's flare lights our sky tomorrow, there will be no negotiations, no shelter deep enough, no second chance. We will witness the impartial edge of physics, a reminder that survival has always been provisional. And yet we listen. We string radio dishes across deserts, build X-ray eyes in orbit, and tune laser interferometers to hear space-time breathing. Against engines that can melt planets, our response is wonder. Fragile, yes. Curious, always. In the cosmic ledger, that curiosity matters. It turns pulse into pattern, danger into data, fear into story. The dead stars speak, and we learn to translate. How many pulses sweep over Earth each night while we sleep? How many bursts missed us by luck alone? Somewhere a newborn Magnetar is winding its field, counting down centuries until a quake brighter than galaxies. Somewhere 2 neutron stars spiral together, their mutual gravity singing bass notes in the fabric of reality. Within those intervals, between ticks, between flares, life unfolds. Oceans tide, forests breathe, people dream beneath skies seeded with invisible triggers of apocalypse. We live inside a clock whose hands are forged from annihilation. In the silence between pulses, we hear our own heartbeat. Fragile, fleeting, and profoundly alive. Not lost, not safe. Just turning with the light until the next sweep of the dark.